Hi everyone, welcome to the Wednesday live stream from Chem Help ASAP. Let me make sure I'm centered here and my volume is okay. All right, so this week, as you can tell from the title, we are going to work with significant figures. So I'm not covering a particular chemistry topic. First, we're going to just go over the rules for significant figures for different kinds of calculations, and then we're going to apply those rules to some chemistry calculations. So it'll be all different kinds of chemistry calculations. So I do recommend having your calculator ready. I have my calculator ready to go. And let's get started with our sig figs. All right, so addition subtraction has different rules than multiplication division. So we're going to start with our addition subtraction rules, and then in just a few minutes we'll go ahead and do our multiplication division rules. Okay, so addition subtraction. You are looking for the number with the fewest decimal places, and that number with the fewest decimal places is going to limit your answer. So again, it's helpful to state the rule, but it's nice to see it in practice. So we're just going to start with a really, really easy question here. Let me switch over. So if I put these two numbers into my calculator and I add them, I get this answer. But that decimal is really small. But does that have the correct number of sig figs? Okay, since we're doing addition, we need to count up the number of decimal places. So in my first number right here, I have 4 decimal places, and in my second number, I have 3 decimal places. So this 3.211 will limit my answer. So I can only put 3 decimal places in my answer. Well, right now, of course, I have 4. Again, I just wrote down what my calculator gave me. So I have too many sig figs, so I'm going to need to round to this 3rd decimal place. So my answer is going to be 4.7, that decimal. And actually it's going to be 80 because this 9 gets rounded up. So that is my final answer. So you can see how we're counting up. It's easy to get confused and you start just counting numbers. We want to count up decimal places. Okay, so let's do another just really simple one. So I have this one here where I've mixed a little subtraction and some addition. So first let's just write down, if you put these numbers in your calculator, what answer does your calculator give you? So if I put those in my calculator, I get this really long guy. 2, 4, 8, 3, 2. Okay. Oh, I see I need to increase my volume a little bit. So let me do that really quickly, make sure that everybody can hear me. So hopefully that is a little bit better and I can move my microphone a little bit closer too. Okay, so back to our problem. We have lots of decimal places here. So never trust your calculator to give you the correct number of sig figs. On the off chance that it does, it just happens by random. All right, so let's count up decimal places in each of the 3 numbers that I added and subtracted here. So in my first number, I have 1, 2, 3, 4, 5, 6. This has 6 decimal places. This one has 3, and this 2 has 0 decimal places. So my 2 is going to limit me. It has the fewest decimal places. That means this long number that my calculator gave me, I'm going to drop all of those decimals. And this is actually going to round to 1. And I know that feels very weird. Now, I did particularly choose this one to give you one with a really long decimal and then one with none, but these are the rules we use for addition subtraction. Okay, what do you do if you have scientific notation? So if you look at these bottom two problems, we're going to deal with scientific notation. Let's take the one on the left first. Now, of course, you can put these in your calculator and get an answer out, but it's tough to compare the number of decimal places here because I have different exponents. So what I'm going to do, since both of these numbers are 10 to the 4th and this one is 10 to the 3rd, I'm going to convert this first number into a number that uses 10 to the 4th. So I'll show you what I mean. So that 8.32 times 10 to the 3rd, I'm going to write as 0.8320 times 10 to the 4th. So does that make sense? So I moved the decimal so that I could have this as a 10 to the 4th in that format. And now I can compare the decimals on all three of these numbers so I know which one has the fewest number of decimal places. Because you can't compare the decimal places. You can't say that one has 3 decimal places and this one has 4 when you've got exponents in different places. So I'm going to go ahead and actually write these other two numbers underneath this one. I'm just going to stack them. I think that's also a really easy way, especially when you have a lot of numbers, to compare the decimal places. And I'm just going to rewrite this one, 0.0035 times 10 to the 4th. And it's also nice to just confirm that all three of these numbers, they are raised to the same exponent. Okay, so now if I put this in my calculator, I'm going to get, oh, nope, not that answer. Sorry. 0.06. I got a little too eager to put that 6 in, didn't I? Okay, so this is what my calculator gives me, and now I'm going to compare decimal places, and you can see I've actually got 4 decimal places for all three of these numbers, so having 4 decimal places in my answer is correct. This one, again, can be kind of tricky if you didn't recognize that 10 to the 3rd, you needed to convert to a 10 to the 4th there. Any questions about the scientific notation? Okay. Again, with the addition subtraction, because scientific notation moves the decimal place, you want to make sure that you've got the same exponent for all the numbers you're adding or subtracting, so you've got the decimal place in the same place and comparing. Okay, let's go on to my next scientific notation. Now this one, I have 3 different exponents here. So I am actually going to put them all in 10 to the negative 4th. So I'm going to rewrite each of these. Okay, so this one, my first number, I'm going to move the decimal 2 places. Okay, my second number stays the same. I'm going to try to line up these decimal places too, because then it's easier to see, I think. And then my third, okay, and I'm going to add all of these together. Again, you can see that they're all 10 to the negative 4th now, and it's really easy to compare the decimal places. Okay, so let's just, like we did before, just write down what the calculator gives us, and then we'll decide how many decimal places we need. So if I add all of these together, I am going to get 707.852. Again, that decimal is not okay. Times 10 to the negative 4th. And now I'm going to decide my decimal places. So I've got 2, 2, and 3 decimal places, so I need to round this number to just 2 decimal places. So that would be 707.85 times 10 to the negative fourth. But we're still not quite done yet because this is not proper scientific notation. So let's get it in proper scientific notation. We need to take this decimal place to the left 2 spaces. And that is going to change that 10 to the negative fourth to a 10 to the negative seventh, a 7th to the negative second. Words are hard tonight, apparently. Okay, so this is addition subtraction. Again, when you've got numbers in scientific notation and they have different exponents, that's, I think, is the most difficult part of addition subtraction. Let's make sure there are no questions. Okay, good. Before we go on to multiplication division. Okay, so when you're doing multiplication or division, what you want to do is you want to count up the total number of sig figs in whatever number you're working with. And the number, again, with the fewest total sig figs is going to limit your answer. So in addition subtraction, we looked at decimal places only. In multiplication division, we look at total number of sig figs. Okay, so again, I think this is easier to see when you actually do an example. So let's do a couple examples. All right, so we're going to take our first one, again, really, really easy. Just, plug it into your calculator. And when we do that, we get 673.762. Of course, that is not to the correct number of sig figs. So now we want to count up total number of sig figs. Again, we're not looking at decimal places. So this 3.02 has 3 sig figs, and 223.1 has 4 sig figs. So my 3.02 limits my number of sig figs to 3. So my correct answer here is 674. Again, I'm rounding to this place so the 7 rounds up. Okay, easy, right? All right, let's go on to the next example to the right here. Again, this is just a division problem. So I put this in my calculator, and this is what my calculator gives me. It gives me a lot of decimal places. 24193 times 10 to the 6th. Make that decimal place a little bit bigger. All right, so now I want to count up sig figs in both of these numbers and see which one limits me. Well, my 5.035 has 4 sig figs, and my decimal here actually only has 2 sig figs. So I didn't actually write the rules down for zeros, but remember that these 5 zeros here are leading zeros. They are not significant. So for a 0 to be significant, it needs to be to the right of the decimal and to the right of another significant digit. So these zeros are to the right of a decimal, but they are not to the right of a significant digit, so they are not significant. As opposed to this 0 here is actually a captive 0. It's in between 2 significant digits, so it's automatically significant. So it is important when you're counting up your sig figs that you are aware of your rules for zeros. This is also why sometimes it's easier just to convert numbers like this into scientific notation, because that will automatically get rid of especially like these leading zeros here, which are not significant. Okay, so to our problem, this number is going to limit us. We should go to 2 sig figs only, not this massive amount that the calculator spit out. So my final answer is actually 1.6 times 10 to the 6. Okay, questions? All right, good. I think we're set. Let's keep going with this. So now we're going to work with a little more sig figs down here on the lower left, right here. Again, once we're in scientific notation, all your zeros are significant. So this 0 is significant, but also you can see it is to the right of the decimal and it is also to the right of a significant digit. So, you can also confirm with just your regular rules as well. So if I'm going to put these two numbers in my calculator, this is the long decimal I get out. And that's 10 to the negative fifth. Okay, so let's go back to our original numbers. Let's count up sig figs and see what we got. Okay, so my numerator has 1, 2, 3, 4, 5 sig figs, and my denominator has 3 sig figs, so my denominator is going to limit me. So I need to round this answer to 3 sig figs only. So that is going to be 1.31 times 10 to the negative fifth. Okay, and then let's go on to this big guy over here. So for the last problem, I did kind of a mixing of multiplication and division. It doesn't matter if you've mixed them up. The rule still stays the same. So first, if you were to just put this in your calculator, let's see what the calculator actually spits out for us. So the calculator is going to give us this answer right here. All right, so now we need to decide how many sig figs. All right, so I'm just going to take this one number at a time. So my numerator over here has 4 sig figs. My denominator also has 4. I have, again, 4 sig figs here. 1, 2, 3, 4, 5 sig figs here. And this denominator has 1, 2, 3. Again, just reviewing these rules for zeros because I know that tends to trip people up. These are our leading zeros. They are to the right of the decimal, but they are not to the right of a significant digit. These zeros are to the right of the decimal, and they're to the right of the 2, which is a significant digit, so they are significant. So these 3 digits are the only sig figs in this number. Okay, and it looks like that denominator there is going to limit our answer, so we need to round. So we can actually do this a couple ways. So we can just round here like this. Remember, this 0 is not significant. It is not to the right of the decimal. Or if you want to be really sure, convert it into scientific notation. So that would be 5.35 times 10 to the third. And then you don't have to worry about that 0 accidentally being significant. Okay, so this is just, again, reviewing the rules for both addition, subtraction, and multiplication, division. And next, I want to do problems where we're going to mix it up. So we're going to have some addition, subtraction, and some multiplication, division, and see how these fit together. Okay, so there's a question. How many significant figures would... I am just going to write this number down. I'll do it in a different color. So that is 0.20400. Yeah, all these zeros, like, it makes it so tricky. It's so frustrating. Okay, so this 0 here is a captive 0. It's in between 2 significant digits, so it's automatically significant. These 2 zeros here are to the right of the decimal, and they're to the right of a significant digit, so they are also significant. Now, in my number, I put a 0 here. That is not significant. That is just a placeholder so you can see the decimal place a little bit easier. So we have 5 sig figs in this number right here. I know those zeros are really, really tricky. Again, if you can convert to scientific notation, it's why I love scientific notation. It makes it really easy to do the sig figs. Okay, let's go on and let's start mixing up our addition, subtraction, our multiplication, division. Okay, so, and this is obviously a chemistry question. Oh, no, sorry, I'm not mixing up yet. I'm just going to chemistry questions. I forgot what questions I put in what order. All right. So if we are calculating molar masses, then we are doing addition, subtraction. I guess we're doing a little bit of multiplication, division too. So now this is going to depend on your periodic table and how many decimal places your periodic table has. So when I write down my molar masses for each element, of course, I'm drawing them from my own personal periodic table. Your periodic table might have a few more, or it might have a few less. You're just going to have to, use what you've got, especially if you're taking a class and your teacher or your professor wants you to use a specific periodic table, then make sure you're using that periodic table. Okay, so let's just get these molar masses down. So again, if I'm using my periodic table, it gives me the molar mass of iron as 55.845 grams per mole. These decimals are just not showing up. And then oxygen is 15.9994, again, grams per mole. Now I'm going to multiply iron by 2 because I have 2 irons, and oxygen by 3. So there is something I want to note. This 2 and this 3 here, those are called exact numbers. When you have an exact number, you have an infinite number of sig figs. So those exact numbers will never, ever limit you when you're counting up sig figs. You can consider this 2 here and this 3 here to have an infinite number of significant figures. So we're really just focused on the decimals here. So if I plug this into my calculator and I calculate this molar mass with all of the digits, I'm going to get 159.6882 grams per mole. But of course, the question is, did I give it the correct number of sig figs? Well, because this is addition, subtraction, I'm looking at decimal places. So actually, let me put this in a different color. So I have 3 decimal places in iron and I have 4 in oxygen. So my molar mass of iron limits me. I need to have 3 decimal places in my final molar mass. So I need to change this to 159.688 grams per mole. Again, if your periodic table gives you a molar mass of iron with 4 decimal places, then you would have 4 decimal places in your answer. It just depends on what your periodic table gives you. And I know there are many periodic tables that only give like 2 decimal places for all molar masses. So then that would limit you, of course, to 2 decimal places for all of your molar masses. Okay, so I missed that one. Convert that one to scientific notation. Yeah, that's actually okay. So going back to Jay's question, hold on, let me get this decimal in. Okay, 20400. Okay, so to convert that into scientific notation. So when you're doing scientific notation, you always want to have one significant digit to the left of the decimal place, but only one. So right now we don't have any. So I'm going to need to move this decimal place over one spot. So this will come 2.0400, and that is times 10 to the first. So that would be how you would convert that one into scientific notation. And you can see I've kept these zeros here because they are significant. They're to the right of the decimal and they're to the right of a significant digit. And the same for this 0 in between the 2 and 4. Again, it's a captive 0. It is significant. Okay, just checking on questions there. All right, so I've got another molar mass question here. All right, so let's get these elemental masses first. Okay, so again, this is from my periodic table. Aluminum is 26.98153. And of course, that's grams per mole. Chromium is 51.9962 grams per mole. And of course, oxygen is the same as I had it up there. 15.9994 grams per mole. Now this one's got a lot of multipliers here. So my aluminum, let me get rid of that. I don't know what that is. It's going to be times 2. My chromium, this is just kind of a going back to calculating molar mass. So remember that 3 is a multiplier to that 2. So I'm actually going to multiply it by 6 here. And my oxygen is 3 times 7 or 21. So this is a molecule that has a very large molar mass. Okay, so putting this into my calculator, I get 701 is very massive. 2766 grams per mole. Again, these multipliers here are exact, just like these guys are exact. So they have infinite number of sig figs. So I'm just focused on the decimal places from my molar masses. Okay, so I have for aluminum 1, 2, 3, 4, 5 decimal places, and then 4 in chromium, and again 4 in oxygen. So my answer needs to have 4 decimal places, and right now I have 5, so I just need to round just a little bit. 972. Oof. I'm mixing up all my numbers tonight. 277 grams per mole. Okay. Yes, and that's 4. I'm just miscounting. Okay. Apparently I need some coffee tonight. Okay. Any questions? 10 to the -1. Yes, I'm having a very difficult time here with this. This should be 10 to the -1. Thank you, OG Benchmarks, for catching my mistake there. That is 10 to the -1 because I moved it over to the right one. Any other questions? Okay. Let's go on to our next page. Okay, so this is, again, I've just pulled a gas law question because I wanted to show how to do sig figs when you're doing just multiplication division. So the molar masses were really using sig figs in addition subtraction, and this is an application of a chemistry problem where we're only doing multiplication division and we want to be able to do our sig figs. So this is just a classic gas law question. So we've got a weather balloon initially at 298 Kelvin. It's got a sample of helium at 1.75 atmospheres. The balloon is released. The temperature drops down to 273. The pressure drops to 0.95. And we have a final volume of the balloon at 65 liters. And we want to know the initial volume of the balloon. Now, I don't want you to get too caught up in the chemistry of this. I really just want to show how we put the numbers in, how we're going to count the sig figs and get the correct number of sig figs out. So don't worry if you haven't done gas laws or you don't know how to do this problem. I'm going to put all the numbers in and then we're going to work the sig figs. And you can see I've actually put in the equation that we're going to use right now anyway. Okay, so I'm just going to plug in all of the numbers that we know, and we're going to solve for our variable and get the correct number of sig figs. Okay, so we're going to start with 1.75 atmospheres. We are solving for volume 1, and our T1 is 298 Kelvin. And we have all of the numbers for the right side. So that's 0.95 atmospheres. Our final volume was 65.0 liters. And our final temperature was 273 Kelvin. Okay, so again, I just want to show you all of the sig figs here. So this is pretty easy to solve mathematically. We're just solving for V1 here, and it's all multiplication division. So we're just going to use our multiplication division rules, which means we're counting up total number of sig figs. So first, if you put that in your calculator, I'm just going to write down what my calculator gives me, and that is 38.517 liters. And now let's look at sig figs. Okay, so I have 3 sig figs here, 3 in the denominator. This one only has 2, 1, 2. This one has 3, and this one also has 3. So this 0.95 atmospheres is limiting my number of sig figs. So my answer can only have 2 sig figs. So let me switch back. So I should accurately report this as 39 liters. Again, I don't want you to hopefully get too confused or caught up in the chemistry of it, but just seeing the math. This is all multiplication division, so we're just counting up total sig figs. The other thing I do want to point out is when I was counting up sig figs for the 65.0, this 0 is significant. Again, it's to the right of the decimal, and it is to the right of a significant digit. Okay, good. No questions. Looks like I didn't make any not thinking mistakes on this one either. Let's go to another one. Okay, so here is just a simple conversion question. So again, this is going to be multiplication division only. All right, so I'm going from gallons to milliliters. Again, I'm just going to write this out because you probably don't have this conversion off the top of your head, but I just want to again show how we apply sig figs into these chemistry questions. Okay, so we've got 1.25 gallons, and I'm actually going to string together a couple of conversion factors just to have some more numbers in here. Okay, so in 1 liter, there are 0.264 gallons. And then, of course, there are 1,000 milliliters in 1 liter. Okay, so first, again, I'm just going to plug this into my calculator and get a number out. And, of course, I get a rather large number. Milliliters. Okay, let's count up sig figs. Because again, we're just doing multiplication division. I'm just counting total sig figs, not decimal places. So let's go to green. So my 1.25, that has 3 sig figs. My conversion factor from gallons to liters, that has 3 sig figs. Now, what's interesting about this conversion here from liters to milliliters is that is another one of those exact numbers. So by definition, there are exactly 1,000 milliliters in 1 liter. So this conversion factor, again, is considered to have an infinite number of sig figs. So it will never limit you in your sig fig calculation. So both of these other two numbers have 3 sig figs, so I'm going to need 3 sig figs in my answer. So that should be 4730 milliliters. Or, of course, I can convert this into scientific notation. It's totally fine. And that would be 4.73 times 10 to the, I have to move it 1, 2, 3. 10 to the third milliliters. Again, either one is fine. Oops. This 0 is not significant because it's not to the right of the decimal, even though it is to the right of a significant digit. Another thing that I just want to mention in terms of sig figs here is, I looked up this conversion factor, and you want to make sure any conversion factor that you get from a table or you ask Google or anything like that, make sure it has at least the same number of sig figs as whatever number you're starting with. So if I had used a conversion factor with only, like if I didn't have that 4 with only 2 sig figs, then my conversion factor would have limited my answer, and I would have lost a sig fig in whatever measurement I made first. So you always want to make sure your conversion factors have at least the same number of sig figs as whatever you've measured, and really ideally they would have more sig figs. So it would have been better if I had added another sig fig to that gallons to liters conversion, but having 3 is still okay. So I just want to throw that out there. Okay, I've got another chemistry question here, and this one is going to mix up my addition, subtraction, and my multiplication, division. So this is a calorimetry question. I am trying to calculate how much heat I need to raise a 5-gram sample of water from 10.3 degrees Celsius to 85.06 degrees Celsius. So again, I'm going to have addition, subtraction to calculate delta T, and then I'm going to have a multiplication, division to calculate Q. So I'm going to put all the numbers in. Again, I've given you the equation here because I don't want you to get lost in the chemistry of it. I really want to show you, go ahead and put in the numbers for the math so that we can do the sig figs. Okay, so first I'm going to calculate my delta T. I'm actually just going to do it over here. So delta T is just my final temperature minus my initial temperature. So in this case, it's just the 85.06 degrees Celsius minus 10.3 degrees Celsius. So it's not that difficult of a question. Okay, so if I do that, then my delta T is 74.76 degrees Celsius. So that's what my calculator gives me. Now, using my rules of sig figs, I've got to use my addition subtraction rule. So I'm looking at decimal places. So I have 2 decimal places in my 85.06 and only 1 in my 10.3. So my answer should have only 1 sig fig. Now, because I'm going to take this answer and move forward with it and do more math with it, I'm not actually going to round it yet. I'm just going to put a note. I like to put a little line underneath where I need to round. So that means as I carry it forward, I know how many significant figures it should have, but I'm just carrying the extra digits so I don't introduce rounding error. So if you round every step, especially if you have a lot of multiple steps, then those errors start to accumulate and you end up with either a completely wrong answer because you've rounded a lot, or an answer that's enough that you might get some points off. So especially when you're putting these numbers in your calculator, I would say just leave it in your calculator. Like leave that 74.76 in your calculator. Don't clear it out and then do the next calculation and use that answer. At least that's how I do it. Okay, so let's plug in our numbers that we need into our Q equals MC delta T. And again, we'll move forward with that 74.76, but a reminder that we need to round to that tens place. Okay, so in this case, we have a mass of 5.0 grams, specific heat of water. And again, because this is something that I looked up, I want to make sure that I have plenty of sig figs. So I'm going to use all of these sig figs. And that is joules per grams times degrees C. And I'm kind of running into my delta T calculation there. Okay, so let's just separate that. And of course, this gets multiplied by my delta T, which I'm going to go ahead and write down 74.76, but again, I'm going to put my little line underneath to remind myself, remember, it should be rounded to the tens place. You're just trying to avoid error. Okay, so if I put this in my calculator, I get 1,563 and lots of decimal points. Clearly, this is not rounded to the correct number of sig figs. Okay, so now I need to calculate. Now I need to count up sig figs for my multiplication division. again, I'm switching rules. So addition and subtraction, I was looking at my decimal places. Now I'm looking at just sig figs. So my 5.0 has 2 sig figs. My specific heat of water has 4. And remember, you calculated this delta T. It actually only has 3, even though I wrote down an extra one. That 6 is not significant. But in this case, my 5.0 grams is going to limit me. I need 2 sig figs. So my Q, again, I can do either this, or I could convert to kilojoules, right? That would be easy. That would take care of everything. Or I could use scientific notation. And all of these, I have 2 sig figs. So it really just depends on what makes the most sense to you. Any questions? Okay, good. Okay, so the last problem that I wanted to do was a stoichiometry problem, because again, it's a mixed problem. We're going to have to do some addition subtraction to get some molar masses. And then when we do the actual stoichiometry part, we're going to do multiplication division again. Okay. So actually, the first thing I want to do is I want to balance this equation. This needs a 2 right here. Always do stoichiometry with a balanced chemical equation. And because I'm given grams here, I've got to convert to moles. And because I want grams of lithium hydroxide, I'm going to go ahead and get the molar mass of both of those molecules. Okay, so lithium oxide. Again, I'm using my periodic table, my molar masses, which may have a different number of decimal places. So lithium's molar mass is 6.941 grams per mole, and oxygen, again, is 15.9994. And I'm just going to go ahead and write this out for lithium hydroxide as well. Again, lithium is the same, 6.941. Oxygen, 15.9994. And hydrogen is 1.00794. Okay, so for my lithium oxide, obviously this is multiplied by 2. So if I just put this in my calculator, I'm going to get 29.8814. And now to do sig figs here. Again, addition, subtraction, I'm looking at decimal places only. So lithium gives me 3 decimal places. Oxygen gives me 4, so I'm going to limit myself to 3 decimal places. Just like for the calorimetry problem, I'm just going to put a line under that decimal place that I'm going to round to. I'm going to keep that 4 moving forward and just put round to the correct number of sig figs at the end of the calculation. Let's do the same thing with lithium hydroxide. And if I do this one, my calculator gives me 23.94834 grams per mole. Okay, so let's count up again. Lithium is 3, oxygen is 4, and hydrogen is 5. So again, my lithium is going to limit me, so I'm going to round to the 3rd decimal place right here. But again, I'm going to carry all those digits forward, and I'm not going to actually round until the very end of my calculation. Okay, so for the stoichiometry part, now I'm into the multiplication division, so I need to make sure I switch in my mind which sig figs rules I'm using. Okay, so I started with 2.50 grams of lithium oxide. I'm using my molar mass to convert into moles. So this is my 29.8814. Again, I'm going to put my line here just so that I keep it in mind. Now my stoichiometric ratio. And this is a 2. Again, that's why you always balance your chemical equation first. That is lithium hydroxide. And then I need one more conversion. I just need to convert that into grams. So this is 23.94834. Again, I'm going to put my line under the 8 there. Grams of lithium hydroxide. Okay, so I put that in my calculator and I get 4.00723 grams of lithium hydroxide. And now let's do sig figs. Okay, so I started with 2.50. That has 3 sig figs. My molar mass, remember here, I rounded to 4, so I have 1, 2, 3, 4, 5 sig figs. Your mole ratio is another one of these exact numbers, so it has an infinite number of sig figs. So we can even just say, hey, that's got an infinite number of sig figs. And then my molar mass for lithium hydroxide has 1, 2, 3, 4, 5 sig figs. So it's looking like my 2.50 grams of lithium oxide is going to limit my final number here, and I have 3 sig figs, so I'm going to need to round to this decimal place right here. So for correct sig figs, the answer would be 4.01 grams of lithium hydroxide. Okay, good. No questions there. As you do your chemistry questions, you'll come across more complex examples here. I think when students are doing these, the most common mistake I see is when they do addition subtraction, they forget that they're just supposed to look at decimal places and they look at total sig figs. We do a lot of multiplication division when we do our chemistry problems, so that's the rule that really seems to get remembered more than the addition subtraction. So just make sure you remember that these two rules are different. And if you're doing addition subtraction, make sure you look at those decimal places and not the total number of sig figs. Well, thanks so much for joining me for this week's live stream. If you have any requests for any other future live streams for topics you want covered or problems that you would like to see worked, please feel free to email me, and I would be happy to do that for you. Also, I always forget, but yes, I also do individual and group tutoring if you need help in any of your classes, and that can be both high school and college level classes. I can definitely do that. Again, you can email me at Karin@chemhelpasap.com, and that will be up on the screen in just a moment. So thanks again for joining. Bye.